So if you've been following the AI boom at all, you know the main story, right?
Oh, yeah.
It's this massive global race to build just enormous amounts of computing infrastructure.
Huge power-hungry data centers.
Exactly. These giant centralized hubs that are basically keeping all the large language models running.
Mhm.
And, that centralized cloud model, it's been the unchallenged foundation of this whole wave.
It really has. The assumption in the industry was pretty simple. Scale equals power, and that power had to be centralized in the cloud where all the GPUs are.
But now it feels like that core assumption is starting to wobble a bit. We're hearing major figures, people like Aravind Srinivas, the CEO of Perplexity, suggesting a really potent counter-narrative. And the idea is, what if inference, so the actual running of the model to get an answer, what if that starts to run on device more and more?
And if that happens, the whole economic model for the centralized cloud it starts to soften over time.
Yeah.
But what's fascinating here, and we should probably clarify this right away, is that this isn't a prediction that data centers are going to become obsolete.
No, not at all.
The cloud is absolutely going to remain critical for, massive model training, for huge context windows, all that stuff. But the data really suggests we're entering a phase of, let's call it architectural rebalancing.
Architectural rebalancing, I like that.
Yeah, the question is shifting from if we use AI to where we use it. We're optimizing for efficiency, privacy, and honestly, for the executives listening, for cost stability.
Okay, so let's dig right into that. Let's unpack the core question. Why is local processing suddenly a viable alternative now when it wasn't really on the table 2 years ago?
All right.
This deep dive, we're going to explore exactly why this shift is credible. We'll try to define what tasks belong on your laptop versus in the cloud, and crucially, lay out the hybrid architectures that leaders really need to be evaluating today.
And that credibility question is so important because it really comes down to this perfect convergence of four main factors. We're talking about technical breakthroughs and just some hard economic realities that are all hitting at once.
Okay, so give us those 4 factors, and let's really try to hit the aha moments, the points that should matter most to everyone listening.
First up, we've just got massive efficiency gains in the models themselves. We've kind of moved past the brute force stage.
Right, it's not just about making them bigger and bigger anymore.
Exactly. These smaller instruction-tuned models are just constantly improving their performance per parameter ratio. They're unlocking genuinely useful tasks, things like really high-quality summarization or code completion, but at a dramatically lower compute budget.
So you just don't need a 100 billion parameter model for every single job.
You really don't.
So the models got smaller and smarter, which I guess leads right into the second factor.
Yeah.
The actual hardware in the devices.
Precisely. The Silicon roadmap is just relentlessly accelerating this shift. We're seeing this proliferation of dedicated AI processing units, specifically NPUs, or neural processing units.
And those are being built right into new laptops and phones.
Right into them. And these chips are designed specifically to speed up the matrix operations you need for running AI locally.
So what's the real tangible benefit of having an NPU in your laptop right now?
Well, the benefit is immediate, and it's kind of threefold. First, it drastically shrinks your latency because the data isn't making a round trip over the internet.
Okay.
Second, it gets rid of those expensive cloud egress bandwidth charges. And third, it just shifts the whole computational load from the expensive server farm to the hardware that you already own.
Cutting down on data movement costs.
Yeah.
That feels like a perfect segue into the regulatory side of things, which you just can't ignore anymore.
That's number 3. Privacy and sovereignty. If you process the data locally on the user's device, you just dramatically reduce data movement. Sometimes you eliminate it completely.
And that makes it way easier to comply with rules like GDPR.
So much easier, especially in regulated fields like, say, finance, defense, or healthcare. The data never has to leave that protected perimeter, which just simplifies the whole compliance burden.
And finally, let's get to the bottom line. The dollars and cents. This has to be the biggest driver for any CTO or CFO listening.
The fourth point is all about cost exposure. Cloud AI spend is, by its nature, volatile.
Because it's pay as you go. You pay for every single token.
Every time. And so demand spikes can lead to these spiking...
Okay, but doesn't buying thousands of new laptops with NPUs doesn't it just move the financial risk? What happens if the next big model architecture makes all that fixed CapEx obsolete in, say, 18 months? That's a real risk.
It absolutely is, and that's the critical trade-off. This shift requires a much longer-term hardware plan and a real commitment to standardized deployment. You're managing inventory now, not just virtual machines.
Right.
However, for many, the stability of the cost and, the reduction in compliance risk often outweighs that hardware depreciation risk, especially where data protection fines are really severe. It's a risk mitigation strategy as much as a cost-saving one.
That risk analysis definitely makes the shift feel more credible. So, okay, knowing why the shift is happening is one thing, but
Right.
how do leaders actually decide what moves? You can't just move everything. It has to be strategic.
You're right. And we can actually draw a pretty clear line in the sand between what works great on device today and what still absolutely needs the cloud.
Okay, let's start there. What are the current winners for on-device processing? What tasks are ready to make that jump to the MPU right now?
Think about anything where the data scope is really restricted and local, so things like generating summaries and translations of documents or emails that are already on your laptop
The data's already there. Sending it out is just adding cost and risk.
for zero gain. It also covers things like contextual helpers inside productivity apps, where the model only needs to see a limited workspace, like suggesting a correction inside a document you're writing.
And I've got to imagine this is huge for people who aren't always connected to the internet.
Oh, precisely. Fieldwork is a perfect candidate. Imagine a repair tech in a basement with no signal trying to look up a 400-page manual.
Yeah, that's a non-starter.
Exactly. Offline drafting, policy lookups, reliable speech transcription on a phone. These are non-negotiables. And then for regulated industries, think about handling highly sensitive notes like client triage or patient intake forms, where that data cannot legally leave the device.
So a good rule of thumb seems to be, the smaller the context, the more sensitive the data, the closer to the user that model should probably live.
That's a great way to put it.
Okay, let's flip it. What is the cloud still the undisputed champion of? What's it going to be for the foreseeable future?
Scale, complexity, and shared knowledge. So first, you still need the cloud for large context reasoning over just massive data sets, what we call big corpora. If the context window is huge, the memory and processing needs just push it right back to the data center.
And what if we're talking about more than just text?
Right.
Like video or really complex multi-step reasoning?
Then you definitely need the cloud's heavy lifting. We're talking about heavy multimodal tasks like high-res video analysis or complex agentic orchestration.
What do you mean by that? Agentic orchestration.
That's where you're running several different models and then stitching together the results with multiple external tools or APIs. It's really complex.
Got it. And what about knowledge that's not just on my laptop, but it's shared across the whole company?
That's where the cloud is essential. For team-wide grounding, we're talking about RAG retrieval augmented generation.
Right, running AI against the company's internal knowledge base.
Exactly. Your internal documents, your HR policies, proprietary research, that requires strong, centralized policy control and high observability across the whole organization, just to make sure everyone gets the same correct, auditable answer.
So if you need one source of truth for 10,000 employees, that has to stay central.
And finally, the cloud gives you that indispensable burst capacity. When you have those sudden massive spikes in demand like during quarterly earnings or a product launch or a big incident, you have to scale up instantly. Devices just can't do that. You need that massive centralized buffer.
So the key takeaway here is really clear. The choice is not binary. It's not cloud or device.
Yeah.
It has to be hybrid.
It's intrinsically hybrid, yes.
Right.
The architecture has to be woven together to use the strengths of both.
So the focus has to shift to architecture diversification.
Correct. And we're seeing 3 core hybrid options emerge that leaders are starting to adopt, each with a different kind of risk-reward profile.
All right, walk us through those 3 approaches. Let's start with the one that's most focused on the end user.
That would be the device-first cloud assist model. Basically, you run a compact model on the device for, say, 90% of your tasks.
Right.
And you only call the cloud for necessary escalations. So when a prompt is too complex, or the local context isn't enough, or the model itself signals it has low confidence.
So the key there is just keeping data local as much as possible.
As much as possible. Only syncing encrypted summaries or cached embeddings when you absolutely have to.
That makes sense. It maximizes privacy for the user.
Yeah.
What about the middle ground for a company that wants control but doesn't want to manage every single laptop?
That's the Edge VPC inference model. You host the models in a secure virtual private cloud or a colocation facility that's physically close to your users.
So like in a major regional office.
Exactly. Think of it like having a really secure, heavily monitored library in your company's backyard instead of relying on the giant public library downtown. It satisfies data residency rules for sensitive prompts, but you still maintain that strong observability and policy control that's really hard with a fully decentralized model.
And the third option. It sounds like it's a cloud model, but it uses the device to make the cloud safer and cheaper.
That's it. Cloud with Smart Client.
Yeah.
You stay cloud-centric, maybe because the task is just too complex, but you use the device's NPU to offload key jobs before the data ever leaves.
Like what kind of jobs?
Things like pre-processing, post-processing, and crucially, data redaction. This cuts down on the number of tokens you're sending to that expensive centralized model, which reduces your risk and your cost at the same time.
Okay, that gives us three really solid options. Now let's put on the CFO or CTO hat. We need a clean framework to compare these. How do we decide?
We can use 4 key criteria: latency, unit cost, privacy, and observability. And when we compare the 3 models, device first, edge, and cloud first, the trade-offs become pretty stark.
Okay, let's start with latency.
Device first is the clear winner. It's almost instantaneous. Edge is very good because it's nearby. Cloud is variable. It depends a lot on your network and the current load.
And unit cost.
Device first has the lowest cost per task, but only after you've paid for that initial CapEx. Cloud first is pay as you go, which, as we said, can spike. Edge VPC is somewhere in the middle.
Now for the big one, privacy.
Device first is the strongest, hands down. The raw data never moves. Edge VPC is also strong because you control the data residency. Cloud requires a lot of active management, strict controls, strong contracts, but the data is still moving across vendor networks.
And finally, the management headache. Observability.
Right. This is where the decentralized approach hits a snag. It's much harder on device first. You need complex client logging. But observability is really strong on both edge and cloud because you control the server environment completely.
So you're basically trading maximum performance and privacy for centralized control and an easier time with audits.
That's the core trade-off.
We've covered the what and the why. Now let's get into the mechanics. How do you actually operationalize this, especially with auditors and compliance teams watching every move you make?
Governance can't be an afterthought. It has to be built in from day one. Since data is moving between different paths, the first step is just documentation. You need to create DPIAs, data protection impact assessments, and really detailed records of processing that spell out the logic for when you use a local path versus a remote one.
Whoa, hang on. For listeners who might not work in compliance, what exactly is a DPIA, and why does the processing location make it harder?
Yeah, good question. So a DPIA is basically a risk assessment. It's mandated by rules like GDPR. You have to analyze the risks of processing data, especially sensitive data.
Okay.
When you move where that processing happens, you change the jurisdiction, the security controls, everything. So you have to justify in great detail the legal basis and security for every single path, device, edge, or cloud.
That sounds like a lot of paperwork. Beyond that, how do you actually control the model that's running on maybe thousands of different devices?
You need very strict content controls. That means explicitly excluding customer data from any training, which should be standard practice anyway. But also, and this is crucial for audits, you have to pin your model versions.
Pinning model versions.
Yeah. If an auditor asks what model generated a specific result 6 months ago, you have to be able to cryptographically prove the exact version that was used on that specific device at that exact time.
And what about the hardware itself? What should we be focused on?
Well, beyond the MPUs, the source material really highlights memory bandwidth and secure enclaves. These are foundational security features that isolate sensitive processing. You also have to ensure managed distribution and signed updates for your models. You need to know that the model on the device hasn't been tampered with.
This all sounds like a pretty massive undertaking, both architecturally and from a policy perspective. How does an organization even start this without getting totally overwhelmed?
You need a clear, structured plan. The sources suggest a 90-day evaluation plan is probably the best starting point, broken into 3 phases.
Okay, phase 1, weeks 1 and 2, discovery.
That's your inventory phase. You have to inventory all your candidate workloads, and you tag them by sensitivity, latency needs, and context size. From there, you pick 3 manageable, high-value, low-risk use cases. Something like local doc summarization, mobile transcription, and maybe an offline Q&A tool.
Then phase 2, weeks 3 through 6, the thin slices build phase.
Yep. You ship device-first prototypes right away. The most critical part here is building in that cloud escalation path from the start. Then you start measuring your key metrics, the most important of which is the override rate.
The override rate, that sounds like the key metric for proving this is actually viable. How high is too high?
It really depends on the task, but let's say your override rate, so how often the device model failed or had to escalate to the expensive cloud model, is above maybe 15% for a simple summarization task. If that's the case, your device model just isn't efficient enough.
So you're looking for a low override rate to prove the device model can carry its own weight.
Exactly. You're also measuring the basics like latency and the cost per task.
And the final phase, weeks 7 to 12, that's the decision point.
That's the compare and decide phase. You A/B test the device model against the cloud model for the same tasks using that hard data. You have to formally model out the total cost of ownership, the TCO, over 12 months, comparing your fixed CapEx against your variable cloud spend. And based on that, you set your guardrails for production.
Now, for the reality check. We can't talk about a shift this big without being honest about the risks and the pitfalls.
Oh, absolutely. First, we have to acknowledge the hype risk. Not every workload is going to fit on a device. You can't just slash your cloud budget thinking device. AI will solve everything. You have to maintain that cloud capacity for the heavy jobs.
And I imagine the operational reality of managing thousands of decentralized endpoints has to be a little terrifying for IT teams.
It introduces significant ops overhead. Fleet model distribution, updates, it's complex, especially when you consider NPU fragmentation across all the different device types from different manufacturers. You need specialized tools to manage that sprawl.
And finally, what about the security trade-off? You're pushing processing to a less observable environment.
It's a definite trade-off. Your endpoints are inherently new attack surfaces, so those devices have to be rigorously hardened. We're talking about enforcing OS versions, demanding disk encryption, having remote wipe capabilities. If you trust a device with a proprietary model, you have to enforce a strong device posture.
So what does this all mean? For the organizations listening right now, what is the single essential lesson from this whole architectural evolution?
The bottom line, and all the sources agree on this, is simple. Do not bet the farm on a single architecture. Not on cloud, not on device. The ultimate goal is to run hybrid, to measure everything ruthlessly cost per task, override rate, and to continuously move your workloads to the cheapest, trustworthy path that meets your governance needs.
And you can measure that success with those 5 key metrics we talked about. Cost per task, latency, that crucial override rate, citation coverage if you're using R, and ultimately, of course, user satisfaction.
Right. Those metrics give you the quantitative proof you need to justify the complexity and the distributed overhead that comes with this hybrid approach.
So this entire shift is driven by this desire for cost stability and better privacy, by distributing the computational load. But that distribution comes with a really high operational cost and new security challenges. So here's a final thought for you to ponder. If that cost stability is achieved by moving inference to these potentially less observable, more fragmented endpoints, are organizations truly ready for the added operational overhead and the security risks that come with trying to enforce device posture like OS versions and disk encryption on thousands of individual devices that they don't really fully control?
That tension right there between cost control and operational sprawl, that is the question that's going to define AI infrastructure leaders for the next few years.
Something critical to chew on as you design your next move. Thanks for diving deep with us. We'll see you next time.